Welcome to Thursday's edition of Office Hours. Let's make sure the stream is going. Alright. There we go. Live on Twitch. Okay, so for those of you that are actually awake this morning, good morning. I have a couple of, or several questions that I got through email last night, so I'm going to address a few of those. It's mostly about the word problems at the end of your homeworks, so I want to talk about that. Okay, so there's one on each section, 6.1, 6.2, 6.3 that I was asked about, so I'm going to pull those up one at a time. At the very least, I'll set up the problem. Okay. So, when sailing toward a statue, a sailor in a boat observed that at a certain point, the angle of elevation of the tip of the torch, and then, of course, the number is going to change depending on what you have. After sailing another 100 meters toward the statue, the angle of elevation became 39 degrees 50 minutes. How tall is the statue? So this is really similar to that building and tower one that we talked about, the one right before. And the key here to setting up the problem is you have to make two triangles and they have to share a side. So you've got, here, let's look at the setup again. So statue and then a boat. Okay. So here's a statue. Oh, I guess it should be of a... I guess it doesn't have to be a person, whatever. Okay, statue. Alright, I better label it. Otherwise, people might think it looks weird. Okay, remember, how tall is the statue is the question in the problem. So, you need to label it something that you're going to find. So, you've got a boat. And initially, whenever you look up at the top of the statue, you have an angle of elevation. Tip of the torch. Oh, I guess they're talking about the Statue of Liberty, I'm assuming. They never say it. I'm assuming the torch would be at the top of the statue, otherwise it wouldn't make sense. Okay. Alright, whatever. Look at the top. Statue of Liberty holding a torch, sure. Oh, tip of the torch, I'm sorry. I need to... Just entertaining myself here. Alright. And that angle of elevation, 26 degrees. Because remember, it's angle of elevation, it's up from horizontal. And then you sail out another 100 meters toward the statue. So, get a little bit closer. And now when you look up, it is 39.50 is what it said. Yeah. So now that's 39 degrees 50 minutes, which is almost another degree. And to get there, you traveled 100, is that meters? Meters. Okay. Now the key here is you want to know how tall the statue is right there, right? So you've got two right triangles, because, you know, you're going straight up and down right here. So triangle number 1 is the 39.50 one. Triangle number 2 is the 26 one. Here you need to set up equations that have x involved in both of them. And then right here, if you just call the whole length from the first boat to the statue, if you call that some other variable, like w or y or, you know, whatever you wanted to say, and there's otherwise, you could have called y the little one inside the 39 degree statue too, but either way, I'm just going to set up the problem for you, let you try to figure it out. But I think this is probably where you're confused if you're asking this question, is you have two right triangles, two equations to set up. They both involve the opposite and adjacent side to the triangle, so you're going to use tangent for both. So you've got one equation that says tangent of 26 degrees equals opposite. Remember, the 26 degrees would be the whole triangle, would be the big triangle, right? That's the only way to make it a right triangle. So it'd be opposite over adjacent. Remember, because I called y the whole thing. And then the smaller triangle, triangle number 2, the 39 degree one, says tangent of 3950 equals opposite, which is x again. And then now the adjacent is y minus 100. Because you got 100 yards closer, or 100 meters closer. So it is 100 meters shorter than whatever the first triangle was. So the rest of this problem should be really similar to number 22. Pick one of them, solve for y. The top one's probably going to be easiest. Substitute that into the bottom equation, and then it's a mess because you've got a crazy looking fraction, but remember, tangent just makes the problem look longer because you're having to write a lot, but it's just a decimal. So you've got decimal equals x over y, decimal equals x over y minus 100. Should be 3-4 lines of work from there. It should be really, really similar to number 22. And this was, we'll label it 6-1, number 23. So there's the setup for that one. Oh man, my laptop is lagging bad. Okay, my other question was 6-2, number 17. So solve the following side-side angle triangle. Oh, this isn't really a word problem. This is just another law of sines problem. So you've got angle A, and side C. So this is ambiguous case you have to check. And we can check ambiguous case without doing the whole triangle. So 6-2, number 17 is up next. So for me, I'm getting A is 44, or angle A, 44 degrees, little a 54.62, and C is 62. Okay, so you have little a and big A, so that's going to be one of your fractions that you set up. So you've got 54 over sine of 44 equals, and now if you have side C, that should give you angle C. So 62 over sine C. I'm going to make this 4 look like an actual 4 here. All right, cross multiply divide, you're going to have to inverse sine, so save us a little bit of time. C is going to be inverse sine of 62 times sine of 44, all divided by 54. And now we have to see what the calculator gives us, and we have to check to make sure that the ambiguous case doesn't work as well. There we are. Pull up my calculator app. Okay, double check we're in degree mode as always. You got inverse sine 62 times sine 44 divided by 54. You're getting 52.9 out of this. Oh, 54.9. Oh, 52.9, I'm sorry. Okay, so remember, that's only one possibility for C. Because you know A has to be 44 no matter what. So you have to check if the supplement of C would give you another legal triangle. So ambiguous case number 2. Could C possibly be 180 minus 52.9? So could C be equal to 127.1 degrees? Well, check it with the angle A they already gave you in the problem. 127.1 plus 44 is still less than 180. So therefore, you have two triangles in this problem. Okay. In scenario number 1, C is equal to 52.9. In scenario number 2, C is equal to 127.1, which is still small enough to fit angle A in there, which means angle B will be whatever's left over. And then same thing for the first case. So you've got two triangles in this problem. There. Okay. Last question I had today was 6-3, number 19. Oh no, I'm failing my homework. Okay, last one on 6-3. So this is the law of cosine section. A parallelogram has adjacent sides 8 and 15. If the shorter diagonal is 11, find the length of the longer diagonal. So you do, whenever you take a parallelogram and you cut it like this, you are going to end up with two triangles. So 8 and 15, short diagonal 11. That was 6-3, number 19. All right. So parallelogram, let's draw it. Well, it's a parallelogram, so that means that the opposite sides are going to be congruent. So you've got 8, 8, 15, 15. This is the shorter diagonal, which is 11, and I want to find the length of the longer diagonal. Right? I guess this does require a little bit of geometry knowledge because you have to figure out an angle here at some point. So the first step of this is that if you look at either of these triangles, so let me look at laser pointer. So here's a triangle and here's a triangle. Ignore my dotted line for now. You've taken the parallelogram and split it up into two triangles, and you actually know all three sides of that triangle. So you can solve for any angle of the triangle because you have the side. The angle you actually want to find is this one right here. Because it's a parallelogram, it's going to be congruent to this one back here. And again, because it's a parallelogram, the supplement is going to be the angle here, which is going to be congruent to the angle here. So we'll mark that with 2. Okay. So if you just find the small angle, it gives you the measure of the big angle. And then you can use the big angle with the dotted line, because then you'll have a side angle, side triangle, and you can do law of cosines to find it. Okay? So your initial setup to this, the angle you want is opposite an 11 side. So set up law of cosines with 11 squared equals, and then the 8 and 15 can go in any order you want. I'll give it a letter. M, sure. Okay. So do this and solve for the little angle. So I'll write out what you should eventually get to. So M should be inverse cosine 11 squared minus 8 squared minus 15 squared divided by negative 2 times 8 times 15. And then if you call this N, N is just going to be 180 minus M. When you get to the point where you now have N, this is the triangle you want to solve for, because they want the length of the longer diagonal. So that part right there. Do law of cosines to set it up. Okay. All right, so that's a homework review from questions I got online. So hopefully that addresses whatever questions you had there. And we're going to go ahead and move on to our lecture now. And I'll save that scratch work as always. Alright, let's move on to the dot product. So I'm going to go ahead and jump straight into the lecture because we're already 16 minutes in. Towards the end, however our time is, I'm going to talk a little bit about a few things to be aware of. And yeah. Okay. Oh, and then I have an email I need to talk about with y'all if I can find it before the end of today. Okay. The dot product. So what is the dot product? You saw this title probably whenever you first pulled it up. The dot product is essentially how you do multiplying to vectors. So we currently, because we talked about vectors, we know how to add vectors together, which means we also know how to subtract vectors together. But we know how to multiply a scalar to a vector. We know how to take a vector and stretch it or shrink it by something. But how do you actually take a vector and multiply it to another vector? So this is the process that we have. So the dot product. And y'all are used to the little dot standing for multiply in math anyways. But now specifically for vectors, you need to have that little bitty dot visible here. Right? It's called the dot product. There needs to be a dot. So if you see a vector dot another vector, you just take their x coordinates, multiply them together. Take your y coordinates, multiply them together, and then add the results. After you do that, the result is just a number. It's a scalar. It no longer is a vector. So a vector dot another vector just gives you a constant number. There's lots of things this constant number tells you about the relationship between the vectors. We'll talk about a few of them today. But yeah, it's just a characteristic of how two vectors interact with each other. So here, let's find the dot product. Do some examples. So remember, both of these are ways of writing vectors, both as position vectors. So you've got x and y coordinates for both. So v dot w in example number 1 is just going to be 2 times 3 plus negative 3 times 4. So this is going to be 6 minus 12, negative 6. Part B, v dot w. So this is negative 3 times 2 plus 5 times 3. So negative 6 plus 15 equals 9. So x's get multiplied, y's get multiplied, add the results together. All right. Okay, this is going to be one of the most important formulas that you'll have for this section, and then eventually for the exam whenever I ask you stuff about this section. So one of the many ways dot product is used is you have this formula where if you have the dot product of two vectors, it's actually equal to their magnitudes times the cosine of the angle between them. The bottom formula is just a rearranged version of the top formula. They just divided the magnitude v to magnitude w over to the other side. So we use this formula in two ways. If you have all the measures of the angles, you can do the dot product to find the angle between them. Or if you have the magnitudes, oh sorry, what did I just say? You can use this to either find a missing magnitude, or you can use it to find a missing angle. Sorry, I should be a little more clear. Okay, let's just do a problem. Alright, if v and w are two vectors of magnitudes 5 and 7, respectively, meaning v is 5 and w is 7, and the angle between them is 75 degrees, find v dot w. So our normal way of finding dot product, we don't know the x and y components of each of the vectors, so I can't just do, x's and y's. So what I have to do is a formula that says v dot w is the magnitude of v, which they gave us, times the magnitude of w, which they gave us, times cosine of theta, which they gave us. So this is equal to 5 times 7 times cosine 75 degrees. Five times 7 times cosine 75. And we get 9 point, let's say round to the nearest tenth. So 9.1. So the dot product would have been 9.1. So that's just a direct application of the formula. Okay, now you have x and y components, and find the angle between them. Round the answer to the nearest tenth. You can actually get a decent idea for what the answer might be by just drawing it, right? Because v would be 2i 3j, so there's v. W would be negative 3i 4j, so there's w. So it looks like, something 90-ish degrees. We know it's not perfect, but, it's going to be something. We have a rough idea. So we can use the formula to find it. So again, v dot w is magnitude of v times magnitude of w times cosine theta. So here I can actually find the dot product, and I can find the magnitudes. Theta is the thing I don't know. So v dot w is going to be 2 times negative 3 plus 3 times 4. And that's equal to magnitude of v, and we can do this off to the side if you want. Magnitude of v is Pythagorean theorem with 2 and 3. So that's square root of 13. Magnitude of w, and I know I'm writing behind my head, but we're doing something similar. Pythagorean theorem with 3 and 4, which luckily is just 5. There we go. So magnitude of v was square root of 13. Magnitude of w just ended up being 5. And then you've got the dot product on the left. You've got, this is eventually going to be negative 6 plus 12. So 6. So I can just solve for theta. Divide your number over the 5 square root of 13. Normally you care about the square root being on the bottom, but we're just making a decimal anyway, so nobody cares. So just divide and then inverse cosine. So theta is inverse cosine of 6 over 5 square root of 13. Make sure we type that in correctly. Fraction bar and everything. Oh, come on. No! Hold on. Get back in the square root u. There we go. 70.6, if we're rounding to the nearest tenth. Which, seems about right. Remember, our sketch wasn't perfect. So 70.6 degrees. That does not look like a 0. What the heck? Okay, no questions in chat yet. I remember there used to be like, 20 people in here in the mornings, and now we have about 5. I'm just going to randomly stop recording on YouTube. No, I won't be that mean. I'm stuck at home. I got nothing better to do. This is fine. Y'all see my cool new banner? I'm gonna click my name on Twitch and you can see my cool banner. I like it a lot. Okay, let's move on. So one of the most important applications of the dot product is determining whether vectors are going to be parallel or perpendicular. So the key here is if you know properties of the unit circle, if you're comfortable enough with the unit circle. Here's our current formula that we've been introduced to, this dot product formula for angles. Well, if you have parallel vectors, And remember, you're allowed to take vectors and slide them around as long as you don't turn them or stretch them. If you lay those on top of each other, there is 0 degrees between them. They're the exact same. If you take this vector and this vector, and you slide the second one over to the first one, they're actually exactly opposite each other, so there's 180 degrees between them. So 180 degrees or 0 degrees if two vectors are parallel. Well, on the unit circle, cosine of 0 is 1 and cosine of 180 is -1. So the cosine theta part of the formula changes either into the number 1 or -1, and we don't really care which one. Two vectors are parallel if their dot product is plus or minus the product of their magnitudes, because the cosine theta either turns into 1 or -1. So that is, you can use dot product to prove that two vectors are parallel to each other, is the whole point of this. Okay, so determine whether these vectors are parallel. Okay? Okay, so the only reliable way to do this is with math, right? You could draw it and kind of see, but you never want that to be your only reliable method, because the math will prove vectors are parallel even if there's square roots or crazy numbers involved. So, are they parallel? Is v dot w equal to plus or minus the product of their magnitudes? Well, I have the tools to find every single one of those numbers, right? I can find v dot w, I can do Pythagorean theorem on v, I can do Pythagorean theorem on w. So I'm going to find all those pieces. So off to the side, magnitude of v, Pythagorean theorem with 2 and 3. Oh, we saw that earlier, square root of 13. W, Pythagorean theorem with 4 and 6. So that's square root of 52. And that does simplify, but whatever. Okay, so 4 and 13. Well, let's go ahead and do it now. 52 is 4 times 13. So 2 square root of 13. And you can kind of see where that interacts now. So v dot w is 2 times -4 plus -3 times 6. And honestly, where people screw up dot product the most is just losing track of the negatives. So just be sure you have all the negatives correct. Plus or minus, and then square root of 13 times 2 square root of 13. So on the left, the dot product is -8 plus -18, so -26, plus or minus 2 times square root of 13 times square root of 13. So square root of 13 times square root of 13 is just 13, and 2 times 13 is 26. So yes, that checks out. Yes, they are parallel. Oh, why did I write it over there? I just wrote underneath my face. I didn't even have to. So that's how you use dot product to prove parallelness. Parallelness, is that a thing? I'm now making it a thing, if it's not. Okay. I'm not going to go over every single one of these. Just I don't have an example for every single one. It's just I wanted to show you the fact that they, dot product is like multiplication for vectors, and all your normal multiplication stuff still applies here. So you've got commutative property up here, number 1. You've got distributing the u on number 2. 0 times anything is 0 for number 3. V dot v equal to magnitude v squared. That's just related to this formula. If both those vectors are exactly the same, the angle is 0, so cosine goes away. And then magnitude of v times magnitude of v is just magnitude of v squared. So there's that. And then number 5 is associative property. You can put the parentheses anywhere you want. So just normal multiplication property stuff. Just this is your formal, page that tells you you're allowed to do all that stuff. Remember, bolded letters are vectors, and non-bolded letters are scalars. So the C is a scalar in the problem. Okay. Let v and w be two vectors in the plane of magnitudes 12 and 7 respectively. The angle between them is 65 degrees. Find the magnitude of v plus 2w. So I have the magnitudes and I have the angle originally, which is going to let me find the dot product if I need it. Find the magnitude of v plus 2w to the nearest tenth. The way I teach this problem is actually just using triangles because it's a little easier. So let's draw a pre-picture and a post-picture. So you've got v and w. Let's do v like this and w like this. The angle between them has to be 65 degrees. And this is a length of 12, this is a length of 7. So now I want to do the magnitude of the result of v plus 2w, so not just v plus w. So I need to find 2w, which is just twice as long facing the same direction. So it has a length of 14 now. So if I scoot over a little bit, if I maintain the same angle between them, my v is still the same. Nothing has changed about v. But now I'm going to take 2w, my blue vector, and slide it over to the end of v, and I have to maintain the same angle. So 2w, oh, I'm way into there. So 2w, which is a length of 14. Wow, that 4 is bad. Okay. Writing on this laptop is hard. There we go. So I took 2w, I slid it over to the end of v. Now remember, I maintained the same angle, right? So I want to find that vector, v plus 2w. I want to find the magnitude. But I need to be able to find the... I've got to solve this like a triangle problem somehow. So I've got to be able to find one of the angles. Luckily I can. Because remember, originally, right here, this was 65 degrees. So when I slide this over, right here on the outside of the triangle, that is still 65 degrees. Because this was a straight line, and it didn't turn at all. So it originally was 65 back here. It's still going to be 65 right there. So on the inside part of the triangle, it's going to be the supplement of that. So this has to be 115. That's just using this angle here. So I've got a side angle, side triangle. I can just use law of cosines to find it. So what is the magnitude of v plus 2w? Well, I know if I fit it in law of cosines, that squared is equal to 12 squared plus 14 squared minus 2 times 12 times 14 times cosine 115. Wow, I am running out of room. There we go. Barely fit it in. Alright, so let's type all this junk in. We'll go ahead and type the square root. 12 squared plus 14 squared minus 2 times 12 times 14 times cosine 115. I get 22.0. Rounded to the nearest tenth is 22. So we just use law of cosines to solve this problem. If you look at the view and example, there are other ways to do this problem with these properties. I just thought that the example for this one was a little convoluted, so I just used old math to do this one. Okay, orthogonal vectors. So the word orthogonal, I don't know why there's a new word for this. The word orthogonal just means perpendicular. So we're just doing, we just did parallel back here. We're doing perpendicular over here. If two angles are perpendicular, the angle between them has to be 90 degrees, right? That's what perpendicular means. Well, the cosine of 90 is 0. Which means that becomes 0. Which means that becomes 0. Which means the dot product is 0. So if you take two vectors, their dot product is 0, then you have perpendicular vectors. Okay, yeah, and then we're on the last slide here. So determine whether v and w are orthogonal. Just find the dot product. We want it to be 0 if we want them to be perpendicular to each other. So v dot w is 2 times 3 plus negative 3 times 2, which is 6 minus 6, which is 0. So yes, they are orthogonal. They are perpendicular to each other. I don't know why we use a special word for vectors. That's beyond what I've been taught. I don't know. What is the etymology of that? I'll get back to you afterwards. Find the scalar c so that the vectors v and w are orthogonal. Notice how w is... That's terrible typing on my part. Hold on. Why did I split up w? There we go. Much better. Okay. So now we want the dot product to be 0, but we actually have a variable inside of the definition of w. So v dot w is 3 times 4 plus 2 times c, and we want that to equal 0. So c is the only variable in the problem. So you've got 12 plus 2c equals 0. So 2c equals negative 12. c is negative 6. And that is it for our lecture. All right, orthogonal, pertaining to or depending upon the use of right angles, from French orthogon. I'm not going to try to pronounce it in French. Okay, so I guess we were supposed to be using orthogonal the whole time. Okay, so I will upload this. I'll upload the video here momentarily. If y'all have any questions, please email. Remember, I've been available. I've been getting back to emails I have been receiving within 30 minutes. I mean, I've just been sitting here setting up your lessons and answering emails. That is all I have been doing from 8 to 4 every day. That and doing a bunch of paperwork. So you let me know if you need help with anything. All right, remember tomorrow. Oh, sorry. So end of class period things. There was an email, if I can find it. I guess I'm going to type and then look for stuff. But I do want to talk about or extra credit project. So I did extend the deadline for today. I guess one thing I needed to mention, I didn't realize I had to mention this. It's called extra credit. You don't have to do it. Some people were like stressed out that you were getting so much work in the class and all this stuff. You do not have to participate. It is not required. Hence extra credit. So you do not have to answer the Google form if you don't want to. If you don't answer the Google form, I am assuming that you are not interested in the extra credit. If I can find this email. Here we go. Okay. Oh, I wish I could pull it up on this computer instead. Let's see if I can. No, I don't think I can. It's not working. Is it working? No, it's not. Okay, so you should have gotten a email from Lee College from Dr. Veronique Tran talking about there's an interim grading policy for this spring and summer term. So basically what you're going to do at the end of the semester, for those of you in a dual credit class, and this is every dual credit class, not just me, but you can, instead of taking the grade for this class, you can just choose to take this class as pass-fail. If you decide to do that, then it will not affect your GPA at all. So here, I'll type in the chat, but there is a link that they have in there. I'm going to type it in the chat. if you want to check it out. And they'll provide you all the information that you want. But if you decide that you don't want the C and you don't want it to negatively affect your, because if you're getting an A or a B in this class, you should probably take the grade. But if you decide that you don't want the C, if you after the final and you don't want to anymore, then you're allowed to do that. And then you have all the way till, let's see, May 29th. So you've got well past whenever you know what the grade is in the class. So that is an option for y'all if you decide to. And the other thing, extra credit, the deadline for checkpoint 1 is tonight, and tomorrow there will be no lecture. No office hours, no anything. None of your teachers are going to do anything for Good Friday. Okay. All right. I will see y'all in the future. Please email if you need anything. Bye.